So you installed Odysseus, you grabbed whatever local model someone mentioned somewhere, and then you asked it a few things. And then you quickly realized that it was slow, or the answers were weak, or both. And now you're probably sitting there thinking the tool's overhyped. Here is what's actually going on. The problem is not Odysseus. Odysseus is not the thing answering or processing your prompts. The model is the actual brain doing the work. And if you pick the wrong one for your machine or your task, the whole workspace will feel broken through no fault of its own. You just gave it the wrong brain for the task. So this is the video that will fix that for you. I'm going to give you the exact local models to run with Odysseus through Ollama, the right pick for your laptop regardless of how strong your hardware is, broken down by what you're actually doing, whether it's chatting, coding, or reasoning. I'll show you the real numbers so you stop guessing what your hardware can handle, the exact commands to install them, how to wire them into Odysseus, and then how to test them head-to-head inside of it so you're choosing based on your own results, not someone else's or even my own hype. Alright, so before I start spitting out any model's name, you need the one principle that makes all of this work, because it is the thing that nobody tells beginners. First of all, there is no best local model. There is only the best model for your hardware and your task. And the reason that matters so much comes down to one technical fact. A model that fits entirely in your graphics card's memory runs dramatically faster than one that spills over into your regular system RAM. We're talking the difference between answers appearing almost instantly and watching a model crawl out one word per second until you give up. So picking a model that's too big for your machine does not just run slow, it makes the whole thing unusable. And that's why you will hear me talk about VRAM, your graphics card's memory, throughout this. As a rough rule of thumb with the standard downloads Ollama polls, an 8 billion parameter model usually lands in the 5 to 6 gigabyte range, a 14 billion is around 9 to 10, and 30 billion plus models push into the high teens or low 20s depending on the version and how much context you load. You don't want to treat those as hard law, you want to treat them as the starting point before you test. Match the model that I'll give you to what you've got and everything else falls into place. So let's go ahead and start building your stack. Now personally, the way I think about it is one model per job. This is exactly the shift that will separate people who absolutely love Odysseus from people who end up bouncing off it. You don't want to look for one magic model that does everything. I highly recommend running a small stack, so basically different models for different jobs and switching between them inside the workspace. To make it super simple, there are really 4 jobs that you're picking for. We've got chat, which is your everyday conversation, summarizing, writing, and general use. Coding, where a code-specific model genuinely outperforms a general one at writing, fixing, and explaining code. Reasoning, for the slower, think-it-through tasks like planning, logic, and weighing trade-offs. And finally, a super important one that will completely change the way you think about Odysseus, which is the agentic work. This is when you use the Odysseus agent to actually do things like call tools, browse, run multi-step tasks, all on its own. You also use it directly to access the other tools, like for example, through the agent you can make it run deep research, add to your notes, tasks, and so on. Many people tell me in the comments that whenever they ask Odysseus to add to their notes or to-dos list, it ends up not working. And that's probably because they're not using a model that's suited for agentic tasks. A model that's built for one of these will beat a jack of all trades at its specialty every single time. So the goal is not one download, it's the right 2 or 3 for your machine. So let's go ahead tier by tier. If you would like to skip tiers based on your own hardware, go ahead and navigate to the timestamps in the description and choose the one that you prefer. But starting with tier 1, the weak laptop. If you are on a basic laptop with no dedicated graphics card, let's set expectations honestly first. You are probably never going to run a model that matches ChatGPT on this hardware. And that's not me being negative, it's just physics. You're comparing your laptop to a data center. In this case, your goal here should be different. You should have a private model that actually runs at a usable speed and handles real everyday tasks. And for that case, if you choose one of the models I'm mentioning, it can absolutely deliver. For general use, you want to start with this Llama model right here. It's small, it's quick, and it's genuinely useful for summarizing, rewriting, quick questions, and light assistant work. It's the most reliable, it just runs first model for weak hardware. Now for coding on a weak machine, you want to grab this Quinn model right here. Make sure it says coder. Now this one will not build you a full application from scratch, but for explaining errors, small scripts, and beginner help with HTML, CSS, JavaScript, or Python, a small code specific model will beat a general, stronger one every single time. Now one honest warning, if you've got no dedicated GPU at all, these will run on your CPU. so you expect noticeably slower responses even on the small models. This doesn't make them unusable, just don't expect snappy. Alright, so the weak laptop stack is two small models, which are the Ollama one for chat and the Qwen one for coder. The honest trade-off is that you trade top-tier intelligence for privacy, no cost, and something that runs on hardware that you already own. Now, of course, as I said, these models are not going to do you wonders, so the smart part is that you don't have to stay local only forever. When your laptop model starts feeling too limited, the cheap cloud model I would pair with this is, for example, this one, the Google Gemini 1. It's not the most powerful model out there, but it's fast, dirt cheap, and strong enough for the stuff that weak local models struggle with. So if you want longer summaries, clearer writing, quicker research, it will cost you roughly 10 cents per million input tokens and 40 cents per million output, which in real terms means a small request costs you a fraction of a cent. So you keep local for private and light work and flip to Gemini Flash Lite as a cheap escape hatch when you want the same workspace to feel faster and smarter. And you do that without spending any significant money. For a lot of people, that combination is a great deal. Now, in addition to downloading the models from Ollama, as I will be showing you later on in the video, you don't need to go and generate or even purchase API keys from Google, Anthropic, OpenAI. You can simply go to openrouter.com, create a free account, create a free general API key, and then plug this right into Odysseus. After that, you will instantly get access to a ton of different models, including some free ones that you can easily switch between within the chat session. And if you go over your free limit or you want to test the stronger models without any consequence on your hardware, then you simply fill up your credits right here and then start using the stronger ones. This is not sponsored or anything, this is just a genuinely good service that I recommend. Now, the second tier that we've got is a normal PC. This is the tier where I would stop calling local AI a toy. The answers still won't beat the best cloud models, but they get good enough that I would actually reach for them daily. If you've got a modern computer with a decent amount of RAM or mid-range graphics card, this is the tier to live in. And this stack is the one I would point most Odysseus users to first. For your daily chat model, you want to run Qwen 3 8 billion. Qwen 3 is the general family I would start with right now. It gives you a good balance of quality, size, and practical speed, and the 8 billion fits comfortably on most decent machines. If you only download one general model, make it this one. Now for coding, I would also run Qwen 2.5 Coder. For me, this is the default local coding model I would start with. It's purpose-built for code generation, debugging, and fixing errors, and light enough to be realistic for most people. This is the one I reach for on small web apps, Python scripts, and untangling error messages. Now, if you want reasoning, I would run this DeepSeek model. This one is built as a reasoning model, so it spends more time working through a problem before it answers, which makes it noticeably better at logic, planning, and structured decisions. That also makes it a little bit slower, so you won't use it for every single message, but when you do need something actually thought through, you just simply switch to it. Now, if for example I run the same coding prompt through Qwen 3 and Qwen 2.5 Coder, the general model gave me a decent explanation, but the Coder model gave me a cleaner structure and fewer missing pieces. Once again, that's the whole reason you don't want to use one general model for everything, even if it's powerful enough. So here is the clean starter pack for a mid-range. One brain for each job, all running privately on your own machine. Now, the cloud model I would pair with in this tier and the other tiers as well for when the local models are good but not quite good enough is Anthropic's Claude Haiku. It's noticeably stronger for polished writing, coding help, and tool-heavy workflows without jumping to the expensive top-tier models just yet. It runs around $1 per million input tokens and 5 per million output. So a normal request is roughly a cent or two. Now here's the logic though, and it's the whole reason local matters. If every basic node summary and quick question goes to the cloud, the bill will stack up for absolutely nothing. But if 80 or 90% of your work runs locally and you only switch to Haiku for the quality bump, your cost stays tiny and your workspace still feels premium. That hybrid between these locally and this as cloud is probably the best setup for most people watching this. Now finally, let's go ahead and talk about the third tier, which is the strong machine. Now this is pretty much where it gets interesting because once you hit stronger hardware, size stops being the whole story. Some models are huge on paper but only activate a smaller part of themselves when they actually run. And that changes everything. If you've got a strong graphics card, basically 24 GB of VRAM, a different class of model opens up. For the best all-around model that you can realistically run locally right now, you want to test Qwen 330 billion as your all-rounder. It hits a sweet spot, strong at chat, reasoning, coding, and long context works all at once. And on a 24GB card, it's the first thing that I would actually try. For a lot of strong machine users, the single model covers most of what they need. Now the part that I mentioned, mixture of expert models, something like Qwen 3 Coder 30 billion is technically a 30 billion parameter model, but only about 3 billion of those activate on any given word. So you get the quality of a big model with much better efficiency than a dense 30 billion because only a smaller slice fires per token. For serious local coding, agentic work, reading and editing across files, repo-scale tasks, Qwen 3 Coder is the strongest thing that most people can realistically run. And if you've got a 16GB card and want strong reasoning, we've got GPT OSS 20 billion, which is also worth testing in that range. Another efficient model that does more than its size suggests. So the strong machine options are these. Now, of course, even a strong local setup has a ceiling though for the tasks where you want the premium cloud version. Complex coding, long project planning, serious documents, or agentic work that really needs reliability, the cloud model I would pair with this is Anthropic's Claude Sonnet. It is the premium but still sane pick, much stronger for real coding, agents, and long context work at around $3 per million input and 15 per million output. So a serious request runs you a few cents. If you are running local for most of your normal work, this is the serious mode button that you keep for when it actually matters. Now, a couple honest warnings. First of all, bigger is only better if it runs smoothly. A fast 8 billion you will actually use beats a sluggish 30 billion that you avoid. So don't chase the heavy models for its own sake. And second, you want to keep in mind the storage point that I'll be going over. Alright, so now that you have a better idea of which models to run based on what you already have, let's go ahead and get practical. First of all, you want to head to ollama.com and then you want to open the model library. From here, you will see a catalog of everything that you can possibly download. Click into any model, for example, the weaker machines one that I recommended, the Ollama 3.2. And then if you scroll down a little bit, you will see the exact models to download from. Now, as you will notice, you will see a few options. You will often see the same name with a bunch of different versions and wildly different sizes. One might be 2GB, the other is 3 or 4. Some cases you will find 40 or even well over 250GB. That's not a bug, and you need to understand it before you start pulling models because two things drive that size difference. The first is the parameter count. That's the number with the B after it. A 3B model like this one has 3 billion parameters, a 70B has 70 billion, and a 405B has 405 billion, etc. More parameters simply means a smarter, heavier model and a much bigger file. So Ollama 3.2 3B is tiny and a few gigabytes, but a 70 billion or a 405 billion parameter version is enormous, and that will be 40 gigabytes or 250 gigabyte plus download. Those giant ones are built for serious multi-GPU servers, not your laptop, so unless you know you've got the hardware, you want to steer clear. If you're going to run local AI seriously, you want to keep your models on a dedicated SSD instead of cramming them onto a half-full system drive. Pull what you can and will actually use and delete what you don't. Alright, so keeping in mind the hardware and the storage requirements, let's say I want to download this model for example, all you have to do is go to ollama.com and then click the download button. You can either run this command in your command prompt or PowerShell or download for Windows. Once you've done that, you go ahead and open up your command prompt. And then if I type Ollama list, you will see what local models I've already got downloaded. From here, you want to pull whichever model fits your tier. So for example, let's say it's this one. All you have to do is write Ollama, pull, and then write the model's name. Basically, from the Ollama's page, you click on this button right here to copy the name, and then you write Ollama pull followed by a paste and then enter. Now, like I said, you don't want to download all of them at once like you're collecting them. Pull a couple, get them working, and then test them and then go from there. Now, once you've got it downloaded, it will open up inside your command prompt so you can message it directly from here. You ask it something real like write a single file HTML, or you can just message it, say hi, see if it responds or not. If it answers, then it works. You type /by to exit. Now from here you want to connect it to Odysseus, so you simply launch it like you normally would. You tap the settings and then add models. You paste this for your local model. And then for the API key, you write Ollama. Ollama does not really need one, but if the box wants something, you write that. From there, all of your local models will load automatically. You click add and it should be fully connected. Now the cool thing is that once you download more local models, they should automatically sync with your Ollama API key. Now if you want to add a cloud model as your backup, like I mentioned in this video, all in the same workspace, it's the same idea. You click on this, choose open router, and then you paste your API key. After that, you instantly get access to all of the cloud models, as you can see right here. Now once you've done that, here is what takes you from guessing to actually knowing. And it is a feature built right into Odysseus. You want to navigate to the compare mode, which sends the same prompt to several models all at once and shows you the answers side by side. You can even blur out the model's name so that you're not biased. And this is an amazing way for you to find your model for your work on your machine. You want to run a few tests. For example, for an everyday workspace check, you can give it a messy block of notes and then ask the models to turn them into clean decisions, action items, and follow-ups. And then you just simply compare your chat models. Do the same thing for coding with a simple coding task, and another one for reasoning, for example, handing it a real decision. That way you can see which model gives you the most useful, specific answer for each task. So I noticed that the mistake almost everyone makes is treating Odysseus like it's supposed to be one magic chatbot. It clearly is not, and it was never trying to be. It's a complete private workspace, and it becomes genuinely powerful the moment that you give it the right brains for the right jobs. So if Odysseus felt underwhelming the first time you opened it, the problem almost certainly was not Odysseus. It was the model. If you need the full Odysseus setup or the beginner walkthrough first, these videos will be linked below at your convenience. And if you want more practical local AI, agents, and self-hosted videos, make sure to subscribe to this YouTube channel so you don't miss out on any future uploads similar to this one. Thank you so much for watching this video. If you have found it to be helpful or informative to watch, let me know by giving it a thumbs up. Leave a comment if you have any questions, and see you guys in the next video.